you can see my screen, let's start. Okay, so welcome to Africa Data AI Group Weekly Meetup. I'm glad you are here once again. It's going to be an experience session learning about data, especially for participants and candidates preparing for the data Azure Data Fundamental exam. So I'm going to take us through our core concepts. Before I continue, Toby Kazim by name, and my job role is actually on a solution developer on Power BI and Azure Data Platform. A couple of certification, data engineering and Microsoft Data Analysis. So I'll be the speaker today. So today our major function is, hope my screen is still visible.
Your screen is on.
Okay. So yeah, today today we are here to describe core data concepts, and then I'll take it out. From last times we talked about the workload, the OLTP. Sorry, is my camera on? Okay. Okay, so we talk about OLTP, OLAP, the data injection, some other things you need to know. So today we'll take it up, going to relational data. So not wasting our time. So our objective is to explore the characteristics of relational data, define tables, indices, views, explore relational data workload services in Azure. So identify relational data base use cases. When we talk about relational database, we can actually start from what is actually the first thing that you need to know. We are here about data, but where our data actually store, where organization, where we store our data is actually called a database, either SQL database or NoSQL database. So a database in one word is where data is being stored. Currently we're having a team meeting. The data is being stored somewhere. The technical name or the ideal name for where that data is being stored is a database. So then it's now narrowed down to relational database and non-relational database. So we are taking it from the relational database, which actually we are going to take up some use cases. So for example, a UAT device can be, last time we met, we talked about unstructured data and semi-structured data. We explained that something that can be formed in a grid like is a structured data. We talk about unstructured data like a document database, and unstructured data like a video or music. So IoT device is a very use cases. For example, you have in my organization, we have a check-in device that we sign in when resuming at work, like a fingerprint device. Immediately you sign in, it captures your data with your ID and it store it in a structured way. So that is a use case of a relational database. The data is coming from an IoT device, which is like a fingerprint. It captures my fingerprint and it has a table structure in one database connected to the device. So that is one use case of relational database. Online transactional processing, you are trying another system, maybe your other system in Jumia. It can also fit into a relational database, and also something like a data warehouse where we have large amount of data also fit into a relational database. So the first things we need to know about relational database, we know that we started with database. Database is where we store our data. Now, when it comes to relational database, the word actually comes in from our old set theory in school or function in school, where you talk about tables. So relations, something that are related to each other. So the first thing is tables. One of the key elements when it comes to relational database is a table. Data is stored in a table, and a table consists of rows and columns. So when it comes to a relational database, there is a particular thing, the most important thing you need to know about relational database is it has a fixed or predefined schema, which means that whatever you define from the beginning is what it's fitting. For example, you can see a table on my screen here. This is a table, and I know participants know that how many columns do you have on this table?
Three columns.
3 columns. So if you are trying to store, thanks, Mr. Rashid. So if you are trying to store data here, it means that we have only 3 entities or 3 entities to store in here. We have only 3 records or 3 items. Let me put it in that way to store here. So if, for example, a particular customer ID 108 has something beyond these 3, let's say address, because we have actually predefined this, it can fit into this database, which is what we mean by a relational database, as in a predefined schema. So something you need to have in mind is that when we talk about relational database, it must fit in to what it has been defined from the beginning. So each column is defined by data type too. So for example, you can agree with me that the second column is what here? Customer name. Am I right?
Yes, you are. Yes, you are.
So this customer name actually, when we talk about data type, we know a data type can be, depending on the language or you are using to store the data, it can be string, it can be whole number, integers, varchar, depending if it is pure SQL, you can have number, varchar, a lot of things. So, but in a basic language, this customer name is a string, is a text. So peradventure, you want to store when you are filling the form and you are storing an O number in this customer name, it's likely to turn into error. This is one of the characteristics of a relational database. They go with a fixed schema, what you have defined from the beginning, the kind of data type you have defined from the beginning. If you try to inject the data, another type of data type in a particular column, it might actually throw back an error, which is why sometimes you try to submit a form online and then the form actually tell you, oh, you are here to fill some space is still blank because it does not expect that that place is blank, or you fill something incorrect data there. So for a particular example again, this customer phone number, we have 3 digits first, another 3 digits first, and 4 digits last. So we have 334. If you try to put 443, it might actually throw an error. This is what we mean by a relational database. And I believe with this short example, I believe we know more better about tables when it comes to relational database. Okay, so I will move to the next element, which is actually entities. So when we talk about entities, there was a debate or like a confusion at some times. What's the difference between a table and an entity? So the actual difference is an entity is an excuse me, is a representation of an item which can be physical. So it can be either be physical or virtual, depending on how it is. So, and when you talk about an entity, in this part of scenario, a customer is an entity. You as a customer, a participant is an entity. It does not mean that participant will have his own different thing, but you are an entity that has a lot of attributes and values. So whatever has attribute of value, it can either be physical or virtual. It's an entity. A customer can place an order for a product. That's a particular customer. What is the customer doing? The customer is placing an order for what? Product. So we can classify that a customer is an entity because it can be connected by relation enabling interaction. So something that can be connected by relation is actually an entity. So in a family, each member of the family is an entity. The father is an entity on his own because it's the father married the mother, give birth to the children, as niece, cousin, and a lot of things, and also employ a maid. So that's an entity because, and the father is 12 years old. Let me be realistic. The father is 42 years old. The father has so amount in his account. That type of thing is an entity. So something that has a representation of an item, either physical or virtual, whatever it is actually what we mean by an entity. And this is, and I hope that's also clears an entity and a table. So a table is actually where we store our data, but an entity is actually a representation of an item. So participant trying to sit for the exam, you should actually know the difference between a table and an entity. So I hope that is clear too, and I hope we are better than 2 minutes ago in understanding the difference between data and entity. Okay, so the next key point about data, relational database is actually normalization. So, and when it comes to relational database, normalization is a very key thing. Normalization is a very key thing because without normalization, we are going to explode our database. We are going to store our database with unnecessary information. And what normalization does is it helps to reduce storage, avoid data duplication, which is one of the most important things. It starts with you are trying to avoid data duplication. So once you can avoid data duplication, you can bet with me that you are going to reduce storage and you are going to improve data quality. So for example now, you can see these two tables. Yes, I know we understand table now. We have two tables here, customer and order. You can see in both of them, we actually okay, sorry. Okay, in both table, you can see customer names appears and customer phone numbers appear. Is that right? Is that right?
Yeah.
So this is data duplication. This is data duplication when it comes to relational database, because you are using some amount of memory to store this value, and the same value is also appearing here. So this is wrong, and this is the idea of normalization. The main idea of normalization is to avoid data duplication. And you can see from here that on the customer table and the order table, we have two duplication. Customer name is appearing here, customer phone number is appearing there. It's only customer ID that are not duplicated and order ID. Now, let's see how this can be improved. This is where the idea of relation comes into play. If you remember, we have a customer ID table, which has a customer ID table is a table that is storing the name of customer. And ideally, you can agree with me that on a customer table, each customer should not appear twice. Am I right? And then, Mr. Rashid, you're trying to say something. I don't hear that.
No, I'm not saying anything.
Okay. So on a customer table, each customer should not appear twice. It should just be once. That's the ideal thing. But a particular customer can order multiple times. A particular customer can come today and buy a product from us. The same customer comes 2 days time, buy different products, which was the customer was attended to by another salesperson, and you can see he's still the same customer. So there comes relationship between our order and the customer. So why do we need to be storing the customer name each time? We can actually represent it with an ID. Oh, for example, in this webinar or this training series, we have coupled number of participants. Instead of mentioning their name, we can actually give each participant an ID in regard to their signing in into the meeting. Maybe, oh, Mr. Rashid is the first person to sign into the meeting today. Is participant number 1. So participant number 1 is actually attending so quiz. instead of repeating the name so, you just have to decode it with the customer ID, and this help to reduce data duplication. So what we are trying to say is, in computer, computer store data by string, by characters. It is easier to store 3 characters 100 than this full name. Yeah, you can agree with me. So this help this come to the theory of primary keys and foreign keys. So we assign a key to each customer, which is the primary key on the table, and that particular key becomes a foreign key on the other table. So with that, you can make a relationship between them, and you can see the connection between both of them. Customer ID connecting to customer ID on other tables. So this is the idea of normalization. In a normalized database schema, no data duplication exists other than the key values in the third normalized one. So it's only the key values that is duplicated, which is actually reduce the data, because the computer or computer system store data by number of characters, and data can be retrieved by joining tables together in a query. So I think with this, I believe our participants has a better understanding of data normalization. Is that good?
Yes, it is.
Okay. Okay, so let me proceed. Indexes. So these are another very key things. It's like when you buy a new book, and then you are trying to, it's like when you buy a new book, and then you are trying to read a new book. One of the easiest way for you to go through a book is the page number. Is that right? You can actually, maybe you Mr. Rashid actually is reading a particular book, let's say Database Foundation, and you wanted to quote a particular paragraph, and you want to send to me so that I can look it up. It's easier for you to send me that, Toby, referring to page 2 or page 24, paragraph 5. Using that page number is easier for me to retrieve the information you are passing to me. Is that right?
Yeah.
So the same ideas come to index in database. Index is like a page number, which makes it faster to retrieve queries in a database. So as a data analyst and function as a database or data engineer, you are likely to write queries. So one of the ways to make your query run faster is when the database has indexes like a page number. You can actually use the index and it optimizes the system. So index optimize search queries for faster data retrieval, reduce the amount of data page that need to be read to retrieve the data in a SQL statement. So it comes to that statement, which I actually represented earlier. You want to you are reading a particular book called Database Foundation, and then you want to refer it to me that, Toby, you're referring to this statement. Imagine you put it in this format. Toby, referring to this database is a thing that and stuff. You send that to me, and you expect me to be checking the book looking for that statement. Then when you now send it in a new format saying, Toby, referring to page 24, paragraph 5. This is the so. You can bet it with me that the later one is easier to retrieve. Am I right? Am I right with that? Hello? Can anybody hear me?
Yes, I can hear you.
Well, I hope that is understood. That idea, that concept is understood. So index are things that help us to retrieve data faster. They are like just mirror an index like a page number of a text box. So I hope that's well understood. So the next thing about relational database is what we call a view. And this is one of those things people didn't actually know that it exists. A lot of data analysts didn't know it exists. In a normal, in a standardized system, you should be retrieving queries on a view, not on a table, because a table is a physical based system, but a table is a virtual one. So a view is actually a virtual table based on the result set of a query. We can derive a view from a table. So it's just like you making it something virtual so that you won't disturb the physical one. So views are created to simplify queries so that not all the time you'll be interacting with the main table, and then a view is coming from query. So it can combine relational data into a single pane view. So for example, this is actually a view coming from customer order from a lot of tables. Customers retrieve the order placed by customer 1 or 2 using the view. So for example, create the definition of a view, create view. This is how we create view, but I don't think in the exam you won't need to read code or write code. It's just basic things. So one of the questions that can come is what is a view, or in a scenario case, a view are created to simplify query. An index is created to retrieve data faster, to optimize data retrieval. But a view are created to simplify query, combine data into a single pane view. Do you understand now? So it's like you are creating a view like of your table. You are creating how it will appear at the front end. So let's proceed. So we have actually talked. These are very key concepts of relational database we have talked about: index, normalization, view, and I believe participants have a better understanding. So while reading for the exam, while preparing ahead, I know going through this recording, you have a better understanding with it. So we move to a concept of non-relational data. Non-relational data. I started with, when it comes to a data world, the first thing any data analyst or data scientist or whatever person working on the data should know, the first keyword everybody should know, the data, what is a database? Even an Excel can be regarded as a database. So a database is wherever we store our data. So for example, I started that a database can either be a SQL or no SQL, not only SQL. A SQL is more of a relational database. So we are moving our concept to non-relational database. So let's proceed. So characteristics of the non-relational database. As the data is something, an influx happen as data gets more increasing day by day. We need to store our data as it comes in. It's not doable anymore to have a predefined schema from the beginning, because we can have a change in how the data has been gathered, how the data is coming in. So there was a development of developing something of non-relational data. So we started with the relational data, the history, the pathway, but later along the way, as the world is changing, the data world is increasing, data are coming in, we need to have some relational data. And characteristics of a non-relational data is this: multiple entities in the same collection with different fields. For example, on this is a particular entity about a customer. So the first customer here is Mark, and the second customer here is Jeff. Now you can see we have this. This is an entity. You understand what an entity is now. So for the first customer, you can actually see what the attribute the customer has. It has telephone and an address. Am I right?
Yes.
So these are attributes of that first customer. Now, when it comes to telephone, you can see something strange happen here. For the first customer has home telephone, the business, and the set. You understand? So, but the second customer only has home and mobile. So it means that we have different attributes regarding telephone. It can either be home, business, cell, or mobile. And you can see they have different structure entirely. Do you get that? So that is a form of non-relational based data, because it's another customer can comes into play and says mine is only business alone. So mine is with another thing, office. Do you understand? So it does not fit into a predefined schema. So this is one of the characteristics of, excuse me, this is one of the characteristics of a non-relational data. Another thing you can see here is when it comes to address, you can see the first ID, the first entity, the first customer has home address and then the business address. But the second one has address in different country, the UK address and the US address with different structure. You understand? So when it comes to relational data, it does not necessarily need to fit into a predefined schema. So when you are sitting for the exam, you can actually meet questions like that. These are non-relational data. They have a different non-tabular schema and often defined by labeling each field within the name it represents. So I think that should be well understood, and I think that is nice. Hope this concept is understood now.
Yeah.
Okay.
Thinking.
Nice. So now, use cases. When it comes to relational database, use cases now. When we are doing when it comes to non-relational database, use cases now. When we talk about relational database, we talk about the IoT, which can also collect a relational data. But now, IoTs can also collect non-relational data. Also require to ingest large amount of data in frequent bursts of activity. Data can be semi or semi-structured. So, like live streaming, you are streaming something live. It's actually like a non-relational data. So, or you are gathering wind information, and it can either go up and down. A lot of turbulence can come. This can be coming from telemetry and IoT device, and it does not necessarily that the data is in a predefined schema, because there may be a new characteristic that's come, maybe a rainfall signal, which has not happened for the past two weeks. So it can be in this format. Retail, nowadays, for retail and marketing, globally distributed data, Cosmos DB, document storage, we have a lot of non-relational data, because the way in a global organization, the way the office in France and the office in Lagos will store their data may be different, and you want to put them in the same database. So for us to have things, there is a room for gathering non-relational database, and we start having non-relational database cases in retail. Gaming, gaming, it can never be, when it comes to gaming, you can never follow a particular pattern. It's just a football game that you wanted to predefine or predict everything from the beginning. This is how you move. You move to the right, you move to the left. It's not going to conform to that pattern. So also gaming, web and mobile. Someone else can click in this way, maybe in a SOL, let's say web testing or whatever it is. A particular user can click here, maybe a particular website doing A/B testing. These are means that we can gather non-relational database. So have it in mind. The question comes into use cases of non-relational database. Gaming is part of it, web and mobile. So I hope that is understood too.
Yeah.
So now, non-relational data. Non-relational data is some example of non-relational data type. Data structure. So we are talking about, when it comes to non-relational data, we are talking about semi-structured and unstructured data. So I've explained semi-structured the last time we met, that they are data that actually can form in a key pair values. So example of some semi-structured data are JSON, Afro, ORC, and Parquet. So a JSON document is a document that is likely enclosed in a bracket. So have all this in mind. You can ask for type of non-relation. This is the type of non-relational data except this. So a JSON and Afro. So I will explain. A JSON is more like, a JSON is more of like, these are kind of the type of non-relational data we have, and they are more than this. A JSON is more like a curly bracket stuff where each field has its own name and has its own attributes by column, followed by column and other things like that. I will try. Let me log in. No, let me put on my VS Code. Maybe I have some JSON code available. Let's see. JSON, I think I have some JSON. Okay, nice. Now, can you see my screen, please?
Yes. Yes.
This is a JSON format. This is a JSON format. This is a JSON format. You can see curly brackets. Curly brackets. It has a name. The name is header. The value of that name, which is header, is like you can structure it like a relational data, but not fully like that. So I have an input. The format of the input is CSV. These are the columns there. The first column is PFA. The value of that PFA is coming from this applied to each name. That's the name of the person. It's calling another table. This is a database entirely. We are writing a database structure here. The second column is a font type. Where should I get this font type? Talk to another table called description. Talk another table called item. From that item, the column you should be returning is the description. Another column, PFA amount. Talk to another table called item. What you should be retrieving for each record is the portfolio value. This is a JSON type code. So when you see something like this, maybe a snapshot in the exam is a JSON type code. I hope that is understood. I hope that is clear. Hello?
Yes.
Okay. So Afro is more like a row-based format. It was created by Apache people, and then each record contained. I didn't have a typical one. I didn't really work with that. I work with JSON or Parquet on the Microsoft platform. But they are more of a row structure. It was developed by Apache. It was Apache that comes into play. This Afro is more of a row-based system. But ORC is optimized row columnar format. It's more of a column than rows. These are other things you need to know about. Afro is a row-based data storing means. It's good for when there's some question that can come into play like Afro, which one is good for optimizing, compressing data in a row structure is more of an Afro. So, but that of ORC and Parquet are more of a columnar database. So I didn't have a Parquet file here also, but the Parquet file is something that is newly introduced. You can use it to store a lot of big data. Instead of I know most of us are familiar with CSV. So when it comes to big data world, we can store those CSV in a Parquet format. So these are things your participants need to know. I hope we get that information right.
Yeah.
So Parquet was also created by Twitter, and then have been adopted by a lot of things. And a lot of us in the data engineering world now make use of Parquet form because of the optimization, and it's really optimized. Okay. So what is unstructured data? So what we have been discussing so far is a semi-structured data. These 4 data types are semi-structured data. Now, we are moving to unstructured data. we are coming from relational, non-relational. Under relational, it must be structured. But under unrelational, it can either be unstructured or semi-structured. So we are coming to this unstructured type. A video is typically unstructured data. An audio is typically an unstructured data. Often used to extract data organization, these are unstructured data. So example of unstructured data: videos, audio, media streams, and documents. A document, a Word document, is an unstructured data because it might not actually follow a particular format. You can start with a paragraph with a bullet, and then from another bullet you move to a table. You insert a table in that Word document. So you can agree with me that it does not follow a predefined schema. You can actually, in a Word document, Microsoft, you can't tie me down to type in a way in a particular schema. You understand? So I can type anyhow it is because you give me a white paper. So a document also unstructured data. So it comes to another terminology, which is actually called NoSQL. So NoSQL actually stands for, is a loose term to describe non-relational, which is where I started from. I started from database can either be an SQL database or NoSQL database. So when we talk about NoSQL database, these are type of database we have: key value stores, document base, column value family base like a Cassandra, graphs database. Graph database is getting more popular now. Graph database is getting more popular, and they can be asked for example of this. So for key values, it can be key values pairs like JSON. Document database also can be in form of a JSON format, can be in form of a JSON format, XML, YAML. Let me remember the phrase. YAML, I think it's pronounced YAML or something like this. YAML is also a document database. So a column family database are Parquet, ORC, I've explained that earlier. Graph database can be Graph API like, let me remember the name of the Microsoft one. There's a particular, is also the Cosmos DB has a graph database, SQL graph database. Also, these are the kind of database we have for storing NoSQL. So these names are actually database. The one you see earlier are the data type. You understand? So you know the difference between data type and a database. Like when you come from a structured data, you have whole number, integer, so. The database can be Excel, can be SQL, can be CSV and stuff like that. So this is a graph database. So where we use graph to relate things to each other. So it makes use of node and edges. So when you see a question that says this so kind of database make use of node and edge, they actually a graph database, and it's something like this. So an employee Sarah works in so department, report to so employee, also report to this so you can represent the database in graph format, and it's actually also interesting too. So I'll just quickly cover some data journey concept: the data injection, the data processing, and data visualization. So I think I mentioned a little bit about this on the last time. So data injection is just a means of relating to okay, let's just treat few questions because our time is fast spent. Let's just treat few questions. Okay. Can you still see my slide?
Yes. Yes.
Okay, so let's just take quick question. So,
Okay.
which of the following service should you use to implement a non-relational database? Which of these following services? So we are talking about, this question is actually talking about service now. So should we use to implement a non-relational? Any idea? Any idea? Hello, participant. Can you hear me? Can anybody hear me? Can anybody hear me?
I can hear you.
Yeah, I said any idea regarding this? The first question here. So which of the following service should you use to implement a non-relational database? So let me help out. Anyway, I want someone, at least an attempt does not mean either you get it or right. We are all learning together.
I vote for A.
So it's actually A because an SQL database is more of a relational database. A graph API, that's an API, Gremlin API is more of also like an API which we can actually consider as a database. You understand? So Cosmos DB is a global wide Microsoft database usually employed by organization that has multi-environment all over, multi-tenant environment all over the world. So it can store a relational database and non-relational database. It can store, it has its own non-relational database, Cassandra, a lot of things you can incorporate. And this is the biggest platform on the Microsoft database system now, Cosmos DB. So I think you are correct. So a nice one for Mr. Rashid, from Mr. Rashid. Nice for attempting that. Good one. I'm even giving you the start. I'm giving you the start now. So nice one. Let me just put this celebration note there. So which of the following is the characteristics of non-relational databases? So I've talked about non-relational databases. Contain table with flat fixed column record. Non-relational database require you to use data normalization technique to reduce non-relational, either schema free or have relaxed schemas. So Ezekiel, any luck from your side?
Hello, Kazim.
Yeah, fine.
Really, I don't have questions.
What is it?
I really don't have a question to ask pertaining what you've shared with us today. And I would say at least it's a knowledge base section. I've been able to learn one or two.
Okay.
To add up to what I want here. Thank you very much.
Okay. So do you have any clue about these questions here? Maybe you have an answer. You can attempt this question and let's see. And let's correct ourselves.
Okay.
The second one, yeah?
You mean I should answer the second one?
Yes.
The second question, you need to answer the objective. Is it A, is it B, is it C?
Which of the following is C?
Okay, so that's nice. It makes sense, and you actually got that correct. So a non-relational database has either schema free or have a relaxed schema. So the third question, which we use to round up for today, you are building a system that monitors the temperature throughout a set of office block and set the air conditioning in each room, in each block to maintain a pleasant ambient temperature. Your system has to manage the air conditioning in 6,000 buildings across the country, and each building typically contains what type of NoSQL data store is most appropriate for capturing the temperature to enable it to be processed quickly. So this is a very technical one. It's coming from a scenario base. Rashid, Adiola, any attempt?
I guess I want to guess, so I'm not sure. C. I'm guessing C.
Okay. Write the temperature to a blob in a Azure blob storage. Okay. Any other attempt from any person? From any other person? Okay, so let me help out. Okay, Ezekiel, you want to add something?
Well, I don't know.
Okay, okay, so this is let me take it from what Rashid said. See, a blob storage is something that store anything. Mostly like you can store anything in a blob storage, either NoSQL or any file. Just the blob storage is where you can store a lot of things. And a blob storage is actually not a good storage for processing. You understand? So it rule out C, because the question says something that can be processed quickly. It can store a lot of things in blob storage, but it's not good for processing. It's actually good for archiving of when you want to archive some data. You can want to archive some videos or documents that you know that you are not interested to process them maybe in the nearest future. You understand? So that's a typical scenario for a blob storage. So let us take the next option. So that rule is out. Rashid, I hope that is well understood now.
Yeah, very, very.
So you are building a system that monitors temperature through a set of office block. Number one, you have some set of office block. Set the air condition in each room, in each block to maintain pleasant ambient temperature. Your system has to manage. I'm trying to solve them. The first thing is you have some office block. We need to set air condition. So there is air conditioning in each block. You understand? And they must give us a pleasant or ambient temperature. Your system also, we have defined that we have blocks. Each block must have its own air conditioning system. Your system has to manage the air conditioning in several thousand buildings across the country or region. So you want to talk to each of these block, each of these air conditioning system in this block from different countries all over the world. And each building typically contains at least 100 air conditioned rooms. So you can see a good one for you to retrieve this is a key structure. Let me try to give an example of how it can work, a key base. Let me just make how that works. We round up. So building one, let me see. Yes. Let's say I can copy this format and let's start here. So our first thing is we have office all over the world. So the name of our company. So whatever format I want to store. So building one is in Lagos. You understand? And it's saying each of them must have a AC. So let's call this AC 01. And you know, each building typically contains at least 100 air conditioning room. So it can either be from what you have seen in stuff before. AC can be another AC 101. 101. Sorry. Let me write it this way. So the another AC, it can be value of AC2. Value 2 is AC 101 LA. So LA is representing Lagos. You understand? So is when you follow this format for each of these buildings. So the next building is for France. Let's say France. AC1 FR. You understand? FR 102 102. So you can see it's easier for you to retrieve in this format. Is that right?
Yeah.
So the answer to that question is a key value store. So this is like a key value store. So it's easier to you to say where my header is Lagos, where the value is 102. You understand? So you can connect to each those AC in that format. So when I want to retrieve a query, I can write a query that says header should be Lagos, then value should be 101. Okay, we can either have number 101, and you know it will actually, you can see automatically when I put, it can actually retrieve the name of that AC 101. Do you understand? So it make it easier for you to retrieve what is in this place. So it's actually a key value store, and I hope this little example give us a better understanding. You can see the data one is very interesting once you structure your data very well. So thank you, participant. I know it has been a very nice session, and I know a lot of participants that could not join will pick up the video recording at the end of the day. Thank you once again. Diola, thank you for hosting me. Thank you, Paul. Thank you. So if you have any question, let me know.
Thank you, Mr. Toby Kazim. Thank you for today. So for the participants, I'm sure we've learned a lot today. Am I right, Mr. Rashid? Because I can see the
Yeah. Very insightful.
As per the guru that you have now. So this is question time for Mr. Kasim. He has asked us his own question. It's time to ask him our own question. Mr. Rashid, do you have any question?
No, not for now.
No. Okay, what about Mr. Ezekiel? Do you have any question? Mr. Ezekiel, are you there? No, I guess. Okay, so Mr. Toby Kazim, there's a way that some of us learn, and is how to relate photos to environment. So, for example, we know that Lagos and traffic, they are 5 and 6. How can we use what you
How
can we use what you've learned, what we've learned, or what you're teaching us to probably solve that kind of issue?
So probably, I hardly hear you.
To profile a solution to
Okay, to provide a solution to Lagos traffic. Okay, so using the data platform, am I right?
an AI.
Okay, so a quick one that came to my mind is you trying to use some stream analytics services, and from there, which is what have been set up in a lot of platforms. So you have some stream analytics that can gather information from a sensor, and it's more of an advanced workload solving that kind of question. Then from there, it injects into a particular stream analytics, filter it within seconds, and gives us information that there's a lot of traffic here. So that's how the Google Map and things works anyway. So they are passing through some stream analytics platform services, filter it in the next seconds, trying to go through another recommendation system, alternate routes. So those data are stored somewhere, and then the recommendation system can pick it up, try to look, oh, yesterday when there was this kind of traffic, this place was better to take. So it suggests a better route. So it's more of an advanced workload, but it's something that a lot of systems like Bing's and Microsoft, Google also is actually making use of. You understand? So using data, you can have a lot of IoT device gathering information from devices from even our motor cars, and then give us some recommendation system, and which is what has been in place already. So I think that problem is something that has been solved. So if going out after this class, I put on my Google map and it recommends to me that there's traffic in Agege Road, please take another route. You understand?
Yes. I just.
So that's how it has been solved. That's connection to how it was solved. Stream analytics, storing data somewhere and other things, and recommendation system immediately is coming from some data you have generated in previous days. So it quickly recommend. All those things are happening in a matter of seconds. So it's more of like a streaming data workload.
Okay. I wanted us to have a pictorial view of what you've taught us, and that's why.
Okay. That's nice. That's nice.
Okay, so before any other question from me, Mr. Rashid, the question now.
Dela, what did you say?
I said, okay, before I proceed to any other question, do you have any question?
No, I don't. I still need to go and read those terms very well.
Oh. So from the business person angle, how do we, Mr. Toby now, how do we sell this kind of things to, owners of organization, for them to get involved? Like,
Yes. Yeah, I understand. How can you translate this to business? Abi, am I right?
yes.
Oh, it is, because actually almost all organizations have data one way or the other. And it comes to a mean that it's not about storing our data, it's how we can get value from our data. So there's a lot of adoption framework and a lot of planning stage. So depending on the organization, starting from SME, going to a big organization like a global organization, is you trying to examine it, trying to have business scenario, case study, the kind of services it is needed, what's the workload, extending the workload to future purposes. So it's actually applicable to all organizations, because you need to have value from your data. So not only you getting data from your system, from an application, you need to add value to your data. You might actually go in a form of data warehouse. You might actually, if it is stream analytics that you need to make use, maybe in a factory that you want to connect some IoT device, capturing some data, streaming it, and then in the manager office, we can see how things are working. It actually goes that way. So the first thing is examine your environment, examine your industry, examine your business case, your objective before you setting up any services. And then if you can narrow it down to your problem statement, it's not just you solving things. We just want to bring this to the business. What is the problem statement, and then getting an expert, a data expert, it actually tell you the way to go. But this is actually where a lot of us miss it. Planning is out of it, and everybody just wants a solution. Solution does not come like that. Solution come from problem, and then problem to planning, and planning to implementation. So I think for each business scenario, the first thing is examine your business, examine your environment. What do you have? What do you want to achieve? So if you take it off from there, you can actually know what services is needed to achieve so and that. I hope that clears it.
Yes, it is. Thank you very much. So before we call it a day and release Mr. Toby, do we have any other question? None from Mr. Rashid, none from Mr. Ezekiel. Mr. Paul? Any other question? Well, I guess not. So thank you very much.
Okay. Thanks a lot.
Mr. Ezekiel.
Thank you.
Thank you very much. Thank you, everyone.
Thank you, everyone.
Thank you, Mr.
Yeah, thanks. So have a nice day ahead. Yeah. And enjoy your weekend. Thanks a lot. Goodbye. Bye.
It's talking about Next.js. So the title of my talk is Stop Using Next.js the Wrong Way, where we're going to talk about the most wonder shall never end. You guess this. Let's see what. Wait now. You.